Good evening to our lecturer Puan Shafinas. My name is Malcolm Analaki Ernest Paul from DDT S2B and matrix number 01 DDT 22F1069. Today, me and my friends here will be presenting our case study for discrete mathematics, and I'll pass it on to my friend Harieesh to start with the first question.
Greetings, madam. My name is Harieesh Raj. My matrix number is 01DDT22F1070. So I will be talking about the first question, which is draw 5 spanning trees from the graph. So speaking about the graph, this is the main graph, which is drawn based on a small part of housing area in Rawang. In this graph, there is 15 vertex and 25 edges. And based on this graph, we have drawn 5 minimal spanning trees, which has been followed the rule, which is the weight, it should be as minimal as possible. And as you can see, these two edges here, which has the weight of 12 and 15, is not used in the minimal spanning trees at all in order to achieve the minimal weight. And furthermore, all these minimal spanning trees have the exact same amount of vertex, which is 15, and have the lesser weight and edges as possible to reduce the weight of the graph. So here is the 5 minimal spanning trees. So next, I'll pass it to my friend Mukesh to explain about the second question. Thank you, madam.
Thank you, Harish. Good evening, madam. My name is Mukesh, and my matrix number is 01 DDT22F1096. Okay, I will be talking about the second question. That is, we use Prim's algorithm for the second question. Okay, as we created the graph, weighted graph, we used the Prim's algorithm. That is, main of this algorithm is the all vertices must be included and the edge must be reduced. That means we must choose the edge and the smallest weight from the weighted graph. So as you can see, we choose the smallest weight from the main weighted graph. That is 1, 6, 8, something. We just choose from the weighted graph that we created. After that, we draw the Prim's algorithm weighted graph. We need to calculate the total weight. It is 4 plus 8 and 1 extra. Then we will get the total is 68. So that's all by me. Next, I pass it this presentation to Malcolm. Thank you, madam.
And now for the third question. Switch to the third question, please. And for the third and final question, which is the conclusion for this overall case study, the first conclusion that we can make from this is this weighted graph is roughly based on the map of a small part of Rawang's housing area. This is because we use Rawang, certain small part in Rawang's housing area as our idea and as our blueprint for this graph that we drew. So that's how it came out, and it's based on this small housing area. And secondly, is this graph can also be used to find the shortest path between two nodes, which is very useful in planning a trip to save maximum amount of time possible, and is to obviously make your trips as short as possible based on the weight that is shown and displayed on the graph. And the third and final conclusion that we can make from this is that there is 5 different spanning trees that we drew above, shows 5 different ways for you to get to reach your destination, and it's useful for planning your route so that you can save as much time and you can use the shortest and the most easiest route possible for your liking. That's all for our presentation on this case study, and that's all from my team. Thank you.
Thank you, madam.
Thank you, madam.